Hey guys, this is an old PowerPoint, so I'm going to do some little editing here. Let's say we're going to get rid of that. Instead, this is the volume lab skill notes. Yes. All right, let's get on with it. Make sure you've already downloaded the notes paper. It should look a lot similar to this into Notability. You're going to go back and forth, trying to fill it in as we go. So, volume is the amount of space matter occupies. Volume, it's how much space it takes up, okay? We measure volume in normally milliliters in our classroom. So that's a little m, big L. We also measure it in liters, like you guys know a 2 liter of pop, right? Or a liter of pop even. And that is a big capital L. And then the other way to do it, those are for liquids. If you're going to do a solid object, you need to do it in centimeters cubed. Even if the object is not shaped like a cube or a rectangular prism, it's still centimeters cubed. And the main reason is because you're still measuring length times width times height, which we'll get to later on. Using a graduated cylinder. A lot of times in our classroom, guys, and I don't know, maybe you've already done it or you're going to do it, you're going to be using a graduated cylinder. This is a graduated cylinder right here. Okay, this is what it looks like. It's graduated because it went to college and graduated. There's the mortar board with the little tassel coming off. It graduated, yay! No, not really, guys. It's graduated. These things right here are called the graduated part of it. It's lines for measurement so that you know that each one of those on this scale right here, each one of those lines is going to be equal to 1 milliliter. And as it says up here, the volume of a liquid is measured in milliliters. Okay. So let's take a look down here. It says a graduated cylinder. Glass container with markings to measure the volumes of liquids. Be sure when you're actually measuring it or pouring that you hold the base of your graduated cylinder when pouring liquids. That way it doesn't spill over. This thing right here is called a meniscus. Everyone say that. Meniscus. Now I just randomly heard you speaking out in the middle of my class. That's kind of funny. Say it again. Meniscus. All right. It's the skin of the water is what it is, and it's the curve of the liquid. You'll see when you're looking at it that it kind of looks, in this picture especially, it looks kind of thick, like it's, I don't know, like it's a skin on the water, like on gravy or something. In some of our graduated cylinders, you won't see that. Those graduated cylinders are specially designed to cause no meniscus. Sometimes there's going to be a meniscus that's thick and fat like this. Sometimes there will be just one little line, and that's it. If there's just one little line, you measure the line. If you see a meniscus, you're going to, like this eyeball over here, you're going to measure the bottom of the meniscus. You can see here that the meniscus actually goes between two lines. You're going to measure the bottom line. So in this case, I would say that is probably closer to 53 milliliters than anything else. Okay? Also, always read from the bottom of the curve. Yep, there you go. All right. You can use the water displacement method. So water displacement method to find the volume of an irregular shape. So an irregular shape is most of the things you see around the classroom and in your world. A regular shape would be a perfect cube or a rectangular prism or a pyramid or a sphere. Okay, those are shapes you can use a ruler to measure the edges, and we'll get to that on the next slide down. But for this, an irregular shape would be, in this case, you see in the picture that we're going to be doing a paperclip. But it's any object. You guys will probably use things like bolts and magnets and things like that in our labs that we do. You find the volume of the water all by itself first. So I'm going to look right here at this meniscus, and it appears that the meniscus right here is actually on 33 milliliters. So on your paper, write 33 milliliters. Okay? Then, so I've done that one. I guess I should put a check mark. All right. Then find the volume of the water and the object. So I very delicately turned my graduated cylinder sideways and slid my paperclip in. Now the water level, as you can see here, the water level has gone up. It is now looking like it's reading at 35 milliliters. Okay? So I have done this step. Now, I'm not done yet. Now, to find the actual volume of the object, I have to subtract the two. Because on the first one, it was just the water. The second one, now I've put it in there, and the paperclip has moved some of that water. It's like you getting into a bathtub. If you fill the bathtub all the way to the tippy top with water, and then you get in, yeah, you know what's going to happen. You take up space. You have volume. So when you get in, you are going to move the water, and the water is going to spill out. So in this case, the paperclip moved the water. So what I do is a math problem over here. 35 minus 33 equals 2. Don't forget my milliliters. So the actual volume of the paperclip is 2 milliliters. Now, what I didn't tell you on the other slide was that an object, a solid object, cannot be labeled in milliliters. 1 milliliter is equal to 1 centimeter cubed. So actually, on the last slide, I should have written to you and told you that the paperclip was 2 centimeters cubed, because it is a solid object. So finding the volume of a regular solid, you guys have done this before. You've done this a bunch of times in math class. So this is old hat to you. It should be fine, but I'm going to go ahead and review it again. But we just measure by multiplying the length times the width times the height. Multiply the measurements and the units. So we're going to label it in cms cubed, centimeters cubed. So we start with 5 centimeters, and we multiply times 10 centimeters. It's supposed to be an M. And I get 50 centimeters squared, right? Because there's 2 cms up there. Then I multiply 50 times 2 cm, and I get 100. And then because there's 2 cms times 1 cm, that becomes cm cubed. So there you go. This block right here is 100 centimeters cubed. That's the volume. That's how much space it takes up. All right, well, good luck with that, and go out there and show me those skills, guys.
Made with Doodlecast Pro.